Okay, we're going to find the term independent of x in this particular expansion. What is the meaning of term independent of x? It simply means the term in which the power of the x is equals to 0. Or another way of saying is the term which is free from the variable. In our case, the variable is x. Now, usually for a binomial expansion question, you are given your first term here, which is the x squared, and your second term is negative 3 over x squared, which has a power of 4. Now, maybe you have already seen the pattern that the first term's power will always decrease while the power of the second term will increase. So using this idea, I am just going to create 5 terms now, because the power is 4, so I will get 5 terms. So you see how I actually create the power of 5 terms here. 5 terms. Okay, now what happens? You know that this first term's power will descend. So 4, 3, 2, 1, 0. Whereas the power of the second term will actually increase. 0, 1, 2, 3, 4. Okay, then whatever that you park at the second term as the power is what you are going to fill up here. So what will we write? 0, 1, 2, 3, 4. Another pattern that you must have seen by now is if you add these two power up, you will get the power of the question, which is the 4. Try 3 plus by 1, you will get the 4. So that is the general pattern. Now, using this, I want to find a term which is not dependent on the x. So maybe most of you, what you will do, you will expand this one. So for choose 0 is 1, then you get x power 8, and then anything to the power of 0 is 1. So your first term is x power 8. Now let's try for the second one. We get a 4, then x power 6, and then we get negative 3 over x squared. A basic simplification will tell me that I am getting negative 12 x power 4. Okay, the next one, the third term will be 4 choose 2, which is 6. Then this is x power 4, 9 over x power 4. I am getting a 54 here. Okay, by now you have already realized that this particular term is not dependent on the x, because I don't have any x term. The x term is being cancelled. Therefore, my answer for this particular question is simply 54. Okay. When you are expanding, you realize, oh, I can stop at the third term. So you don't have to continue anymore. Okay, this is one way of approaching the question. It's like you are literally expanding the entire question. Okay, let's go for the next one. The power in this question is 6, which is slightly larger than the first question. So do I want to repeat the same step like the previous one? If I were to repeat, what will we do? The power here is 6, 5, 4, 3, 2, 1, 0. Okay, doing this might seem easy for you because I am the one who is writing, not you. You are just watching. Can you imagine repeating all this blue color stuff again and again? You might get tired, or it could be time consuming. But I'm not stopping you from trying. You see, the power that you write for the second term is what we are writing as a selection here. So 6 choose 0, 1, 2, 3, 4, 5, 6. Now you make your judgment. Which term will actually cancel the x for the first term, which is this one, and also for the second one? Take a moment and then you inspect. Maybe I will do the first one. If I were to expand, I'm going to get 1. And this is 729 x power 6 and then a 1. So my first term is this. Then my second one. You see how tedious it gets. Then I need to calculate what is 3 power of 5. So this gives me 243 x power 5. Then there is a minus 2 over 5x here. When I simplify, I'm going to get negative 2916 over 5. And this is x power 4. So far I don't see any independent term, and the values that I'm getting are not as pretty as the previous one. Okay, at this point you have to ask yourself, is this method of expanding and finding each term and then selecting the answer a good choice? Maybe not so. So at this point, you need to develop your thinking process. So you just go and aim at the variable directly. When I say variable, it means the first term and second term. You see, the power of the x here and the power of the x here is same. It's just 1 and 1. In that case, when they give you an even number, you can split it into 3 and 3. So I know my independent term is definitely going to be here. Why? You look at this. This is your x, right? When you expand, you will get x power 3. Whereas the bottom one here, it is a x as well, over x. Right? So if I expand, I will also get x cube. But it is at the denominator. So I know my term will cancel out. If you don't believe, let's try it. What is 6 choose 3? I'm getting 20. Then next, 3 power 3, which is 27x cube. Times, there is a negative 2 now. So negative 2 into negative 2 into negative 2 will give me negative 8 over 125, and the x cube is at the bottom. So what will happen to this x cube and this one? One is numerator, the other one is denominator. So it gets cancelled, leaving us with only a independent term. And what is that value? Negative 864 over 25, and this is our answer. See, I'm not expanding everything because I am getting tired. So what I can do, I know that if the x in the question for the first term and the second term is the same, the power of the x, then I can just take the even number and split it into 2. The first term will take a power of 3, the second term will take a power of 3. So let's try with the previous question. Look at this. You are having x squared in your first term, and in your second term you are also having an x squared. So what can you do? The 4 is actually an even number. You can split it into 2 parts. So you can quickly write. So when we write, are we getting the same thing? Let's check. It is a 2 here and it is a 2 here. So I know that this method will always work. Now let's see another variety. Okay. Here. Also, I need to find the independent term, but then I realize the first term has x squared, whereas my second term has x cube. So the shortcut method which I was actually using, it's not going to help me. So do I want to go back to this expansion technique again? Do I want to expand everything? Will it be advisable? Do I want to do all these 5, 4, 3, 2, 1, 0? 0, 1, 2, 3, 4, 5, like that. Do I want to do this? What do you think? Take a moment. Don't you think it's also tedious? Of course, when I write it like this, it is very easy for you to see. All you got to do is balance the power for the first term and the second term so that it gets cancelled. So let's inspect. What am I getting here? I'm getting x power 10. Whereas this one is just x power 0. So it is giving me x power 10 over x power 0. So this is definitely not the independent term. How about this? This is x power 8 over x power 3. It is giving me something in terms of x power 5, not the independent term. Okay, let's check the next one. This is x power 6. Whereas this is also x power 6. So I know, this is where the x get cancelled. So the term that I am looking for is actually here. Okay. It's actually here. Okay, now let's solve. Since I already know that my independent is actually the third term when I expand, then I can just solve it. So what is 5 choose 2? It is 10. And then 3x. So 3 power 3 is 27. X power 6. Negative 1. You see, negative 1 and then multiplied with -1 because the power is a 2 now. So what will you get? 1 over 4x power 6. And when you solve it, it is 270 divided by 4, which is 135 over 2. This is an independent term. Almost we are agreeing on this idea of expanding, but partially. You just listing it in order to see where will the power match. But can you afford to do this when the power of the question is more than 5? Now the power in this question is 12. So we need a standard method. So what can we do? Okay, this is where we're going to see a pattern in order to solve. I realize that every time when I expand, there is only 3 brackets that I'm creating. This goes for the first term, which is my x, comes from here. Can you see that? And then this is for my second term, which is my -3 over x squared. Be careful with the negative, don't omit it. If this is your first term, whatever remains at the back here will become your second term. And then for the first one, this is always the power, which is my 12. Okay, I generally see I have a pattern here. Now what I'm going to do, I need to just think of my powers. But how do I do this? Using a standard method. So what we're going to do, we're going to put an R here. If you put an R here, then this is going to be an R as well. And what will this be? We know that if we add up these two boxes, it needs to equate to the 12. That's the pattern that we saw. Okay, give a try here. 0 plus 5, I'm getting the 5. 1 plus by 4, I'm getting a 5. Like that. It always works. And you can try. You can pause the video and try with the other question. So, how will you fill up this particular box now? It is technically 12 minus the R. Okay, so far you are good. So, we're going to put 12 minus R there. Once you are done with this, you know that you are looking for term independent of x. It means the power of your x is going to be 0. So if I want to crack the value of the r, then I need to get an expression in terms of x. So what I'm going to do, my aim now is to deal with the variables only. Do not care about your constant term. Where is the constant term? This is actually a constant term. 12 choose R is a constant term. It's not going to give me anything in terms of x. So, let go of that. And then this -3 here. -3 to the power of R, it's definitely a value. It's a constant. It is not going to give me anything in terms of x. So, do not bother them. Only focus on your x. So, where is my x? It's here. This one and this one at the bottom. So let's just focus on that and write x power 12 minus r. You expand. And then because the x squared here, it's at the bottom. So you create a fraction over x power what? Look at this. You take the power and you give it to both the numerator and denominator. So we will get x to the power of 2r. When we simplify this, what will happen? By the index law, you will take this and then you will minus with this one. 12 minus r minus 2r, which simplifies to 12 minus 3r. What is our aim? We want to get independent term, which is x to the power of 0. So now you equate this question to x power 0. Okay, now at this point, what can I do? I can balance my power. Compare and you find the r value. 12 minus 3r is equal to 0. My r is equals to 4. Are you done? Not yet. Why? We are finding for the term independent of x. We are not interested with the r value. So what is my r? 12 choose 4. You substitute. You take this value and you substitute here. Then x 8 -3 over x squared power 4. Now you focus only on the constant terms. You can ignore your x variable. So when you are typing into the calculator, you literally take your x to be 1. In your calculator, you can just put the x as 1. And when you solve, let's see what you are getting. 12 choose 4 times 1 times -3 to the power of 4, which is 40,095. Of course, these are some a pattern to help you to digest the question. But if you are a thinker, can you guess the R value immediately? Of course, you can. You can choose to do that method, and I would prefer you to do that method.